Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be discovering everything to do with internal energy for the GCSE Physics curriculum. If you do enjoy the video, please give it a like, share this with someone else who you think would learn something from this video, and also please do subscribe. I'm so grateful for everyone who has already joined our community, but if you haven't, if you've just stumbled across this video, hello, I'm a real life science teacher and my mission is to share my love and joy for science and help you get the best grade you can. So if you'd like to be part of our community, feel free to subscribe, share this channel, and let's get into it. So we need to go back a couple of steps if we're looking at internal energy. So we need to go and look at what state changes means. We've learned this before. I'm going to recap it now. So if we go from a solid to a liquid, remember solids are arranged in a regular way. They have order to them. The particles in a solid are close together and they vibrate at fixed positions. If we heat up a solid, however, it can change state into a liquid, and this is what we call melting. Now, a liquid has more disorder to it. Those particles are able to flow, they have more energy, and that's essentially why they're able to flow more. If we heat that liquid, we can cause the liquid to turn into a gas, and this is through the process of evaporation and boiling, which, by the way, I'm going to distinguish between the two in a moment. However, if we cool down a gas, we can actually reverse this process and we go from a gas to a liquid through the process of condensing. This essentially helps those particles cool down and build closer together and build those bonds together. A liquid to a solid as well. If we cool a liquid down, we call this freezing and we can get back to the original state. Remember that mass is always conserved during the physical changes, and those physical properties can be essentially reversed, and those particles can go back to the position they were in. Remember, there's also a state change called sublimation when a solid becomes a gas and skips the liquid stage. This again, though, however, is a lot less likely to occur in natural everyday life. There is an example of dry ice as a great example for sublimation, but it's less common. Now, what is the difference between evaporation and boiling? Because these two words are commonly used in everyday language to kind of mean the same thing. So just to clarify, evaporation is a slower process, and essentially what happens is the particles are escaping from the surface of the liquid. So you probably will see evaporation as the steam or the vapor that comes off the liquid, especially if you were boiling a pot. However, if you think about boiling, you often see the effects of boiling as little bubbles in the liquid. And boiling essentially happens at a faster rate, and those particles are getting ready to escape through the evaporation process. So boiling and evaporation are very similar, but just helping you clarify those bits for you there. So internal energy is this idea that there is energy found within the particles of a system. So let's say we have a pan of water like we had in the previous picture, and we're heating it up. That pan of water will be able to gain energy. Remember, energy can't be created, it can't be destroyed, but we can actually transfer energy. So we can transfer it through heating a substance. Now, when we provide thermal energy to, say, a pan of water, those particles actually gain energy and they can actually start to move around. And that's why we get that movement of particles from a solid, they're in fixed positions, and then they change state into, say, a liquid or a gas. And that is because of that kinetic energy, that thermal energy that's been provided and has now transformed into a different version or kinetic energy. There is also, like I say, an equation for internal energy, and it goes as the following. Internal energy is equal to the total kinetic energy in a system plus the potential energy. And just to clarify, remember, kinetic energy is the energy stored in objects which are moving. You've probably seen this equation lots of times. No, you don't need to remember it. It is on the equation sheet for you in the exam. But just to clarify, kinetic energy is a half times the mass times the velocity squared. But potential energy, now this is the type of energy that is taken in when chemical bonds break and are given out when chemical bonds are made. And it's the potential those particles have to have that energy there. So we can calculate this in the exam if we were expected to. They could give us some data, we could work out the total internal energy of a system. So if we look at internal energy, remember when we heat up those particles from, say, a solid to a liquid, the heating process, like I said, increases the amount of energy those particles have. And this can either raise the temperature of the system itself, say the pan of water, but it can also change the state. And I'm going to show you, just as a recap, some of those heating and cooling curves you may have seen from Key Stage 3. So these are the heating and cooling curves that you may have seen before. This kind of shows you what's happening at each stage. So as you can see on the left-hand side, we have temperature in degrees Celsius on the y-axis, and along the x-axis, you have time. And as you can see, we have state changes that are shown as a horizontal line. And that's because the temperature doesn't change during a state change. It only changes during those gradient lines, those red or blue lines, as you can see on my graphs there. One thing you could get asked to do is to work out or to plot this data. You could also be expected to work out the boiling point of a substance or the condensing point of a substance. And you can see I've tried to mark those on my graph there. So you can see the crosses show you where, say, the boiling point is or the melting point of a substance. This is something common they can ask you to do. And that is it from me. I have been the GCSE science teacher and you have been curious. If you did enjoy the video, please do subscribe, click the bell so you don't miss any uploads. I am planning on doing some mock revision walkthrough videos of exam questions, specifically long answer questions. Students in real life that I teach have actually asked for some support with long answer questions. So if that's something you also would like some help with, please do comment down below. Or if you have any other video suggestions, I'm more than happy to make those for you. I do also have an Instagram and a TikTok account. All of it is at the GCSE Science Teacher. I do share lots of revision tips over on there as well. So if you want to join that community, please do. It's amazing to have you here. So feel free to subscribe, like this video, share it with someone else. And if you do want more content from me on YouTube, I do have some playlists and some videos attached to the end of this video. So please do go and explore my channel. There are lots of biology, chemistry, and physics videos. And in the meantime, have a fantastic day and I'll catch you in the next one. Bye.